In this video, I'll do a demonstration and an explanation of how I set up HTTPS for my web server, how I set up a secure shell between my web server and my desktop, and what TLS is and what it has to do with HTTPS. So first of all, HTTPS is a secure version of HTTP, which makes use of TLS. TLS stands for Transport Layer Security, which is an encryption protocol used for secure internet communication. So TLS handshaking occurs after the TCP connection has been opened via the TCP handshaking. So during the TLS handshake, the version of TLS is specified, the cipher suite is decided on, which we can see in Wireshark. Then the authentication of the service identity happens, and then the generation of the session keys for symmetric encryption is being sent. So TLS sits somewhere around the session layer of the OC model. Some people say it's on the presentation layer, and some people say it's on the transport layer, but I think it's on the session layer because it has to do with data exchange. So to set up HTTPS for my web server, I first of all installed the Apache web server, which I followed a tutorial for, which you can find on this website. And then I went to this website to follow a tutorial for SSL certificate generation and to combine it with Apache web server. So first of all, I enabled the SSL module. Then I created the self-signed certificate. Once that was created, I configured the Apache to use SSL. And then once that was done, I tested the Apache with SSL. So I'm currently in my Ubuntu server machine. And here is the key and the certificate. And once those were generated, I went to the configuration file to change some configurations. I changed the server name and the port to 443, which is the port for HTTPS, and then the document root to the location of the web page. I also changed the location of the certificate file and the location of the certificate key file. Once that was done, I restarted the Apache web server and I went to OpenSSL to see if everything was working correctly. Here we can see that the self-signed certificate was being returned. Here's the cipher and the version of TLS. And here's some information about the certificate. So once that was done, I went to the Ubuntu desktop machine and I started listening for TLS using Wireshark. I reloaded the web page and I got a response from the server saying client hello. Here you can see the version, although version 1.3 is being used and not version 1.2, because if we scroll down to the supported versions, we can see that version 1.3 was being supported, so that's what it's choosing. Also here you can see the version of TLS that is being used. Here we can see the key exchange and the different cipher suites which are being proposed. So here if we look at this picture, we can see that Bob is the web server and Alice is the desktop, and the desktop wants the web page from the web server. So the web server encrypts the data with the public key from the desktop. Here it encrypts it, and then once the desktop wants to see the data from the web page, it unlocks it using the private key. If anybody else wants to decrypt it using the private key, then it's not going to work, because only the desktop is able to decrypt it using its private key. So we got a response from the server, and then the desktop replied saying server hello. So here it's saying version 1.2 again, but again if we go to the supported versions, we can see that it is using version 1.3, which is here. We can see the key exchange again, and we can see the cipher suite that is being used. So then it sends some application data, and that's how the TLS works. If we go to the web page again, you can see that it is not secure because we use a self-signed certificate. If we would use a certificate which being enforced by a certificate authority, then it's not going to complain about not being secure because it's being renowned, and a lot of companies in the world accept that this certificate authority is trusted.